Domain are all the possible x values that could go into a function. Anything can go into this function. There's no limitations. Anything can go into this function. There's no limitations. If I were to graph that, it would look something like this. And these just keep going forever, don't they? Slightly out a little bit. So x could really be anything in this function. Domain. That's what they're asking you. What can x be? Range is all the possible outputs. This is something new, composition of functions. We'll look at that on the back side. You're putting one value of a function into another. This is how you say it. You ready? F of g of x. Say it. F of g of x. This is another way to write it. The same thing. F of g of x. Okay, that's how you say it. F of g of x. Yeah. F of g of x. It's a tongue twister. Okay? All right. So let's just start with some basic domain here. F of g of x. State the domain of each function. What could x be? This is a linear function. There's no limits. X can be anything. It's a linear function. Okay? So I would say domain is all real numbers. I can plug any value for x into that function. All real numbers. Does anybody know the symbol for real numbers? It's a symbol for real numbers. You've seen it, I believe, haven't you? It's like the paragraph with an R.
I don't know.
That's what the symbol for all real numbers is. Okay? Now, so here, x can be anything. Let's talk about this square root function. In a regular square root function with real solutions, what can you not have underneath the square root? A negative. So what's underneath it says underneath, has to be positive. So we have to figure out what x value, 5x plus 6, will be greater than or equal to 0.
-1.
Well, there's quite a few, so we're going to say
-1 and up.
there's more. Not quite, there's more. So I'm going to solve for x here. Let's see, I'm just going to solve this inequality. So that's -6, 5x is greater than or equal to -6. Divide by 6. X has to be greater, just divide by 5. X has to be greater than or equal to -6/5. In order for it to be 0 or greater, any x value greater than that number is my domain. Okay? That will keep me from having a negative underneath here. So this is how you write it. Domain, or D, is all real numbers greater than or equal to -6/5 for that one. Okay, this is a rational function. What cannot be in the denominator of a fraction? 0. You can't have a 0 in the denominator. So there's only one value that won't work here, and what is that? 6. I can't have a 0 in the denominator. So x cannot be 6. The denominator cannot equal 0. So x cannot be 6. But it can be everything else. So I'd say all reals, but not 6. That's my domain. All right, this one, when it's a negative exponent, you have to realize that that's the same thing as this, correct? Negative exponent, you just put it down on the bottom, or you bring it up to get rid of the negative. Now, the only thing that wouldn't work here is what value of x? X cannot be what? 0. Can't have 0 on the denominator. So this is how you would write your domain. It's all reals, but not 0. So that's domain, okay? All right, Let's do some things with different functions. It's really not anything different than, well, this isn't really. This is saying to add the function f of x and the function g of x together. That's all it's saying. So basically, you're just doing this. 2x squared minus 8 plus x squared plus 5x plus 6, and you just combine like terms. It's just telling you to add the two functions together. So you get 3x squared plus 5x minus 2. Is there any restrictions on the x values in this one? It's a parabola. There really is no restrictions. So your domain is all real numbers. What's this saying to do? Subtract, you take f of x and you subtract g of x. So you have to be careful here. The easy way to do this is just change this to an add and distribute that negative and just change all the signs inside to their opposites. And then you combine like terms. So when you do that, you get x squared minus 5x minus 14. Do you see it? Any restrictions here? No, x can be anything. There's no restrictions there. Okay, don't write too big. And what's this saying to do now? You just multiply, and when you multiply binomial and a trinomial, you can FOIL, you can box, you can go up and down, you can do anything. So I'm going to write them out. 2x squared minus 8 times x squared plus 5x plus 6. I'm just going to FOIL because it's quick for this one. 2x squared times x squared is 2x to the 4th plus 10x cubed plus 12x squared. That's 2x squared times all of those. Then I'm going to do negative 8 times all of these. So I'm going to line them up though. Look how pretty this is. Negative 8x squared plus negative 40x plus negative 48. And then all you do is just add down. So it's really long. It's 2x to the 4th plus 10x cubed. I'm going to combine these two like terms. Negative 40x, and I'm just going to write minus 48. That is that long thing multiplied together. Again, you could FOIL, you can box, you can do vertical, whatever. No restrictions. No restrictions here. It's all reals. There's nothing that x can't be. It's going to be kind of like an upward parabola sort of shape. It's a quartic, remember? Here, you're going to divide. So you have to factor the top and the bottom. I'll show you what I mean. And then check to see if you can reduce. So I have f of x, 2x squared minus 8 divided by x squared plus 5x plus 6. Before I walk away from this, I got to see if I can simplify it. And I can, by looking at the top here, I can divide out a what?
2.
A 2. Don't write too big. And I get this. I wrote a little big. This one's really easy to factor. Factors of 6 that add to 5, 2 and 3. So I'm going to just write that right away as x plus 2 times x plus 3. Oh, but I'm not done. The top can go further. So I'm going to take it down here, and I'm going to realize, of course, that this is a special pattern. And I can write this as x minus 2x plus 2, the sum and difference pattern, over x plus 2, x plus 3. Now look what you get to do. These cancel out. And then you're done. You get 2x minus 2 times, and then over x plus 3. So then you're done dividing, but there's one restriction. What is it on our domain? It can't be what? Negative 3. It can't be negative 3. So the domain is all reals, but not negative 3. Because you can't have a 0 in the bottom. Yeah, yeah? All right, let's have more fun. Okay, hey, let's look at this last one. F of G of 6. So you have to do 3 things. Not quite. You have to do 3 things. So first thing we have to do is plug what into what? 6 into G. 6 into G first. So let's just do that. 2 times 6 squared equals 72. Then I have to take 72 and plug it into what? F. Oh, should be 72 here. And that equals 208. And then I have to do what? Plug 208 into F again. F of G. And you get this. So they're written a little bit different. Depending on the book that you have, you may see either way. Our book writes it like this. Other books may write it like that. They mean the same thing. Okay? Oh, but there's one more thing you got to learn. It's the fishy is coming along and swallowing the whole function and taking that function and plugging it into its x. That sounds like very confusing, doesn't it? Okay, look at you're doing f of g of x. That means I'm taking whatever g of x is and plugging it into the x value of f.
How did you get that?
F of g of x. I'm taking the function of g, the whole thing, and plugging it into where x is. Because remember, this is really just this, right? F of x. But now I have to take all of g of x and substitute it into the f of x. So it looks like this. 7 minus 5, and where x is here, I'm going to put g's function. Yes? Let that sink in for a minute. You good? Now we got to make it pretty. So it's going to look like this. But of course we wouldn't want to leave a negative exponent. So it's simply going to be 7 minus 20 over x. And then you're done. You can't go any further. You can't get a value because you don't know any of the x's. So I just took the x and put it underneath. 20. Oh, but for some fun, they like to do it the other way. Now, you're going to do g of f of x. So you're going to take the function that is g, or excuse me, that is f, and plug it into the x of g. Yeah? Kind of? If you think of it like this, g of x, and you're just plugging f of x into g's x. So it looks like this, okay? So g of x is 4 times x to the negative 1. Where x is, I'm going to put f's function. Very easy to simplify. This whole thing is to the negative 1, so how do I simplify it? You just move it underneath the 4. And you're done. You could write g of f of x equals this. Grand finale. We have a sick fish. It's going to swallow itself.
Cannibalism.
F of x. So basically, f of x is this, 7 minus 5x, but where x is, I'm going to put f function again. Okay, 7 minus 5x, but where x is, I'm going to plug in the f function again. And then you make it pretty.
Oh, yay, pretty.
This is really just put f into itself. That's basically what you're doing, putting f into itself. So all you do now is just distribute. Don't make it naughty. Somebody making it naughty. Yeah.
Making it naughty. She did. Oh, I was like, she did say that.
How's that for a good time?
That's fantastic. We kind of